Okay, so how are we all doing? Yeah. How was assignment 10? Yeah. Good for some of you. So it struck me that maybe I've thrown you into the deep end, some of you anyway, with this assignment 11. When I look at what happened last year with assignment 11, only something like 15% of students actually submitted it, which I don't want to happen this year. So there's maybe a couple of explanations for that. One is that it's considerably more complex than assignment 10, sort of a big-ish thing to do in a language that's brand new to you. The other explanation is that it is in some sense optional. If you've done the other 10 assignments, you've already gotten your full marks for assignments for the semester. And so you don't need to do this, but do keep in mind we're taking the best 10 of 11 marks on assignments, so if you had an assignment that you didn't do as well on as you would have liked, this is your chance to make up for it. So there you go. So with that in mind, I'm going to do a little bit more Java stuff today, but I don't have anything special I want to teach you, so we'll just program something and maybe learn a few more ins and outs of Java. But before that, does anybody have any Java questions they would like to ask me? Yeah. Okay, good. So that's one of the things we're going to do today is write something that's part of a package. So there's these things in Java called packages, and we see those in similar things in Python, but in Python they're usually called modules. They're basically just namespaces to keep all the functions that Java has and all of the classes that Java has from all living in one big global namespace. So for instance, in Python, when we want to use the math functions, we can import math or import specific functions from math, and then we prefix them with math.log or math.square root. Java has the same idea of packages, so that not all of the thousands of classes that are available in Java are always there. So that prevents things like naming conflicts, where in your application you want to have a class called pair, but somewhere in the thousands of classes in Java there's another class called pair that's completely different, but now you need to resolve that. So that's what packages are for, and we'll use one today. Any other questions? So now's your chance. You can even ask me things about the assignment. Everything's clear in Java? Yep. So how to how to create a class, or how to just make a new object?
New objects and lists of objects.
Okay, objects and lists of objects. So let's it's the 25th today, right? Okay, so the question is, how do you make a list of objects? So just to play around, we already have to do something. So what kind of objects do you want to make a list of? You name it. Strings, for example, or what's that? Cards. Yeah. Okay. So you want to make a list of chickens. I don't know. Okay, chickens. So let's make a So there's a chicken. Okay, so I want to make a list or an array, or do you care? Yeah.
For the assignment, do you want it all in one file? Or can we have each class?
You won't be able to put it all in one file. Every public class has to be in its own file, and the name of the file has to match the name of the class. Yep. Yep. So that's allowed. Yep.
Why does every class have to be its own file?
Why does every class have to be its own file? For that, you would have to ask the language inventors who made this decision in 1995 or 93 or so. Yeah.
I've done a program in Java. If you don't put in the public and just put class, it'll let you.
You can still access it as long as you're in the same package, which we'll see what that means shortly. Okay, so we have a chicken, and let's see if that works. This is okay. So we define inside this play class an internal class called chicken. That's just because I was a bit lazy and didn't feel like opening another file to define this thing in there. And chicken, when it prints itself or when it converts itself to a string, gives you the string cluck cluck. Yeah.
If you have 5 different classes, will each class have its own public static void name?
Only the classes that you want to be able to run. So if you want to be able to run the class, then it needs a public static void main. So even for classes that are not really an application, it's sometimes handy to just make a public static void main. What you can put in there is stuff that tests the class to see if it's working correctly. Yep.
In the assignment, you want the public static void in its own file, or do you want the public?
I want them in their own file, and we'll do an example application like that. Okay, so good. So we have this working chicken class, and you want to make a list of chickens. Okay, so for that we need to import something that allows us to make a list. And the one that we've seen is array list. And I'll import something else. So a array list is a special kind of a list. It's an implementation of a list. So I want a list of chickens. Call that CL for chicken list. And that's a new array list of chickens. And if we print CL, then we get, we can just barely see it here. It's these square braces telling us that we have this list with nothing in it. Yep.
The difference between this chicken CL equals blah 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 and array list chicken CL equals blah blah.
This way of doing it here says that I know that I'm creating, even though I'm creating an array list on the right here, which is a very particular kind of list, I want you to forget about exactly what kind of list it is and just treat this as some generic list, and I'm not sure exactly how it's implemented. The benefit of that, of doing it this way, is at some point I may decide that array list was a bad choice, in which case it's only one thing to change which is to say, I might want to change this to a linked list instead of an array list, in which case I only have to change it in one place. That's a handy thing to do. I mean, here you change it in one place instead of two, but imagine that I had a lot of other functions that took lists as arguments, and if they all took array lists as arguments, that means when I changed my mind and decided that I wanted to use linked lists instead, I'd have to change all those functions. Yep.
How many different types of lists are there?
There's two main types, array lists and linked lists, and there's more as well, but that's a question for Comp 2402. Yeah.
Is it like, you know how when you create an array, like a static array, you
Yeah.
just like put like squiggly brackets and write in, you could write in whatever you want. Is
Yeah.
it like that with array lists?
No, there's no nice, easy way to do a static array list that I know of. I mean, the best, somehow the best you can do is create a static array and then put all its elements into a list. But it's just, it's not much more work to do something like, so we can put a couple of chickens into that list. And now when we print it, we have a list with 2 chickens in it, so they each print themselves as cluck cluck. So, that's how you make a list of whatever kinds of objects you want. Replace chicken with card or whatever your favorite thing is. You can add things to the list, and you can remove things from the list as well. So it doesn't matter what kind of class you have. So questions about that? Yeah.
What's an interface in Java?
An interface is just a list of functions that you're allowed to call, and it doesn't tell you how those functions are implemented. So actually, list here is an interface. Every list has the ability to add things to it. Every list has the ability to remove things from it. Every list has the ability to get the value at a specific location and set the value at a specific location. But different lists are implemented different ways. So an array list implements all those operations, therefore it implements the list interface. But the list interface doesn't tell you at all how they work, it just tells you what they are, what the functions look like. Yeah. What does an enumeration do in Java? Yeah, they're a fairly new construct. I don't understand them that well, mainly because enumerations for me come from C and C++, and Java ones seem to be quite different. So they're basically a predefined set of finite set of different values, basically. Yeah.
Arrays are not part of the list interface, right?
That's right. Arrays are something different. We can create a chicken array. So a chicken array looks like this. So remember, when we define a array, or when we create a new array, you have to decide how big it is at the time you create it. So this creates an array of 5 chickens. Now, this is actually a fairly important thing. So this creates this array. It has room for 5 chickens. Now, what are chickens? Well, chickens are these objects, right? So they live off in memory somewhere. So really what this array has in it is a list of 5, well, not a list, it's an array of 5 references to chickens. So when I do this, we can now take a look at this thing. I can say for chicken C in the chicken array. out dot print C. Oops, I already used a variable called C. So here's this chicken array that I've just created. When I print it out, I don't actually see 5 chickens, I see 5 nulls. So I've created this array. This array is big enough to hold 5 references to chickens, but I haven't put any chickens in there yet. If I wanted to do that, I could do something like, chicken array at 2 is equal to a new chicken. And now when I print this thing, the second element, the 2th element, is actually a chicken. The other ones are null, meaning they're not references to anything. So creating the array doesn't actually create the chickens, it just creates enough space to reference the chickens. That's something you don't come across in Python because you only really have lists in Python, and you don't create a list of a specific size with all these blank things in it. You just add stuff and remove stuff. Yeah.
Does Java allocate the memory for like an array of uninitialized variables?
Yes. So it allocates space in this case for 5 references. Any other questions? So it's good sometimes to work with a language a bit and then get a chance to ask more questions about it than just be shown a bunch of stuff. Okay. Clear-ish? Okay. So let's try and do something, see how far we get today. Making something that's not as tough as the assignment, but maybe something we have a chance of finishing today, which is a game. It'll have a few different parts in it. It'll be an easy game. It'll be Tic Tac Toe, and seeing where we get from there. So I wanted to show you packages, and so packages are this way of organizing your classes into things that are related and also protecting them from accidentally being used or being in the namespace of other things that you make. So I want to make a game called Tic Tac Toe. It's going to be its own thing. It'll have a collection of classes associated with it. So I'll make a package called Tic Tac Toe. Now, Java, they did this idea that the class has to be contained in a file with the same name as the class, and they took that one step further, and the class actually has to be in a file whose name is the class and whose directory is the package that the file is in. So if I want to make a package called Tic Tac Toe, the first thing I have to do is make a directory called Tic Tac Toe. Okay, so now I've got this directory called Tic Tac Toe, and I'll create in there one of the classes that I need. So if I'm going to make a game of Tic Tac Toe, what kinds of classes might I have? Yep. A board. That's sort of the most obvious thing. If we sit down and play a game of Tic Tac Toe, the first thing we need is usually a piece of paper and maybe a pencil to mark it with, or if you want to be really fancy, you buy a game of Tic Tac Toe from a game store, and there's like some big X's and O's in there you can put on. But there's some place where we record the play of the game. So let's make a class called board. Now I said this class wants to be in the Tic Tac Toe package. So that's the first thing we note at the top of the class, that this is in a package called Tic Tac Toe. And notice this is already something useful to do because we're creating a class called board, and you can imagine that there may be dozens of other classes called board in dozens of other places in dozens of other pieces of software, because board is like a really, I mean, you make any sort of game, there's going to be a board. I wouldn't like to necessarily have to write Tic Tac Toe board in the name of my class. Just board is good, and the fact that it's a Tic Tac Toe board is somehow captured by the fact that it's in the Tic Tac Toe package. So somehow we save a little bit there. Otherwise, we might get worried. And board could mean many other things. It may have nothing to do with games. It could be something in a lumber mill. Yeah.
So we were doing, we were making this script outside of NetBeans.
Yeah.
Making a package, we call it board in Python, or not Python, Java.
If you made a package and called it board, why? Yeah. I don't know if there's probably nothing in the, there's probably no class called board in the standard Java libraries. But for instance, let's say you were making a video game. You ever see these video game Chariot, where there's these two guys pulling a chariot with a piece of string? So it might be natural in that game to have a thing called string, right, to represent the string. If you try and make a class called string, that's at the global scope, that's going to be a problem because Java already has a class called string. Putting it inside a package that's just specific to your game would resolve that, because if you want, Java can then tell the difference. There's the Java string class, and then there's the other class. So that's why we do this kind of thing. So board is probably safe for now, but maybe at some point somebody decides to take this game and put it in with a collection, make a whole collection of games that you can play all in one application, and maybe one of those other games also has a board class, and then you have a conflict.
Would it not still be okay because it's inside the Tic Tac Toe package?
Yeah, because we put it in the package, it would be okay. If you had two of them, both either in the same package or in no package, then there'd be a conflict. Okay. So what kind of things does a board have? So what does a tic-tac-toe board have? Yep. Vertical and horizontal lines. So when we draw it, we would draw vertical and horizontal lines. But that's really just part of the drawing of it. What kind of things does it store? Yeah. Yeah, so it stores those values of the squares, these 9 squares on the board, and so it needs to store that somehow. So let's think about how we could implement those values on the board. So what kinds of values go in those squares? Yep.
I just had a suggestion. Is that a two-dimensional array?
Yep, we can do a 2-dimensional array, and that's what we'll do. So what will go in that array? What goes on a tic-tac-toe board? Yep. Yeah, so at each location in the board, there's a value there. And what are the possible values? X or O. Anything else? Nothing. Empty. So we have sort of 3 values here, and so let's just give those names. So we have n for none, x or o, n because we need something there. I guess we could use underscore. That's a nice variable name. Maybe gets the point across a bit better. And then x or o, and we'll make these things integers. They have to be something, we'll call them 0, 1, or 2. And that means that, and we'll store these in a two-dimensional array. So the way you declare a two-dimensional array is just like this. So this says that this is an array of arrays of integers. So the first thing we'll have to do is create one of these things. So this new class board that we're defining should have what's called a constructor. That's just a function that has the same name as the class. It'll get called when we create a new instance of this thing. So in this constructor, we want to initialize this variable board with a little b, which is a two-dimensional array. And so really this thing is just a reference to an array of arrays. So we have to fill in all this data. We have to create the arrays and everything else. So we need to do something like board is equal to new integer array 3 by 3. So this creates a new two-dimensional array of size 9. I'm not sure if this actually works. May not. Okay. Sorry. So to compile this thing, we compile Tic Tac Toe board.java. Okay. So it seems to be happy with that. And so there we go. What should we be able to do with our board? Yep.
This is a question. This is 3 rows by 3 columns or 3 columns by 3 rows?
However you want to view it. We can decide how we want to interpret those things. And that'll just, it's just the way that we print it will determine whether it's 3 columns by 3 rows or 3 rows by 3 columns. So we can choose. Yep.
Well, I was wondering too, which number though determines, like if you were to make it 4, which array would be size 4?
If you were to make it 3, 4 like that?
Yeah.
Okay.
Would the array within the array before?
Well, let's find out. So we'll say for integer I equals 0, I is less than board.length, I plus plus. Print line board at I dot length. Okay, so we'll iterate over board.length. Board is an array of arrays. So this will tell us the number of things we print out. Will tell us how many of those arrays there are. And then we'll print the size of each one. And we'll do this 3 by 4. So we get something. And create a new board. Now, here's a funny little thing. When I compile this class, I have to do it from outside. Remember, everything has to carefully match. The directory structure and the class names have to carefully match the packages and the class names. So I compile them and I specify which directory it's in and which file it is, which is really giving me the class name. Now when I run it, somehow Java wants to switch syntax and specify it as if it's inside a Java program. So I specify the package name and then a dot, the class name. There we go. So this, if I create an int array of 3 by 4, so using the dimensions 3 first and then 4, this actually creates 3 arrays, each of length 4. So there we have it. Okay, so what should a board be able to do? What should we be able to do with boards? Yeah?
I just have a question about the array. Can you do that with array list?
Can I do what with an array list?
Can you do two-dimensional arrays?
Yeah, you can do a two-dimensional array of array lists, but it becomes a little bit harder because you end up having to write code that looks like this. So let's say you wanted to do it with an array list. So already the code is getting longer, but now I have to do something like, it's actually a list of lists of integers, and it's a java.util.array list of lists of integers, and now I have to do something like I equals 0, I is less than 3, I plus plus, li.add new array list integer. So that's the equivalent code if you do it with array lists. So an inner loop that counts from 0 to 3 and creates a list of lists of integers. So it creates 3 lists of integers, and then it has to go through and add stuff to those lists because by default they start out empty. In this case, it fills them all with zeros. So it's a little more long-winded than this one line of code here. And there's no reason, at least for what we're doing here, to want to use a list because it's a 3 by 3 board. It's not going to get any bigger or any smaller at all during the game. So an array is perfect for that. I will be changing the values, but you are allowed to change the values inside of arrays. You just can't make them bigger or smaller. So I'll leave that there as a comment. All right, so what do you want to do with your board? What are we going to need to do when we're making a tic-tac-toe game?
Show the position.
So show the board somehow, right? Print out the board. So let's write some function. It's not going to return anything. It's just going to display the board. So as a first attempt, we might do something like so we're going to print it out as 3 rows and 3 columns. So after we print out each row, which is what the inner loop will do, we want to print a new line. And then in the column, will we want something like board at I at J.
Will that not print out the integer though?
Yes, it will. So let's take a let's test this. So indeed, it prints it out 3 rows, 3 columns, but it's all zeros. So that's not what we like. So let's find a nice way of doing that. Well, we have these zeros, ones, and twos, which are nice because they happen to be suitable indexes into arrays. So we can do something like this. Static string symbols. So we create an array with 3 strings in it. One is a blank space, and the other 2 are X and O. And that happens to correspond, the positions in that array happen to correspond with these, the integers that represent these things. And so we can just say symbols at board at IJ. So what's going to happen now? An error, of course. Illegal initializer for string. Really? Oh, this should be a string array. So now it doesn't print anything. Is that right? Yeah, that's right. The board's all blank, so it doesn't print anything. Usually, when you play Tic Tac Toe, that's not what your board looks like, though, right? Usually there's some lines separating things. So let's see if we can put those in there. We'll start with the vertical lines. So we'll do some cheap ASCII art. Now we have our vertical lines. They should be like that. We have the vertical lines, and next the horizontal lines, which we want here. I is less than 2. Almost. Okay, good. So there's something that looks a bit more like the board. All the cells are blank. We have a nice little ASCII art board here. Good. So we can print this thing out. What else would we want to do with the board? Check for a win. Before we're going to be able to get any wins, what do we need to be able to do? Yeah. So add pieces or add marks or set one of the positions. So we want something like so set position I and j to some value x. And for that, we just set the array position, the array at row I, column j, equal to x. Check that that works. We can say b dot set position 0, 0, and set that equal to maybe O. B dot set position 1, 0, maybe set that equal to x. See if it displays properly. Of course, this doesn't need to return anything. Okay, good. So there's the second drawing of the board. 0, 0 is set to x, and 0, 0 is set to O, and 1, 0 is set to x. So we can set positions. What else do we want to do with the board? Yeah. Sure. You want to put some more spacing here. A little bit of extra trailing space after the board. There you go. So if we want to play tic-tac-toe, what else should we be able to do? Input, okay. So somehow we have this board class which handles the back end of things, storing the state of the board and maybe displaying the state of the board. But maybe we want to do a little more and now think about more of the user interface, how the user is going to enter things here. So somehow we need something else, maybe another class here, or something that controls all of this. So there's lots of, in object-oriented programming and any kind of programming, there's lots of ways to do things. But maybe I would like to make a class called game. So let's get out of this board class for now. And so this will really be a game of tic-tac-toe. So an ongoing, a game that actually gets played. So this is the thing that we really want to run if we're going to play tic-tac-toe. So it's going to need a board. And it's going to do the usual thing of displaying the board and then asking the players to alternately make their marks. So let's do that. So for a while, we'll make the players play this, and we'll do something like display the board. Now, there's two players. player 1 and player 2. So let's say player X and player O, and say something like what's that? No, you can't. This is, I want to call this, it's an integer array called players. Okay, so we ask the player to pick their move. So how do we do input in Java? Yep. Yep. So the scanner class is helpful. So let's give that a whirl. And what did I say for game? Okay, so it prints the board, says player X, pick your move. So now we have a question. How does player X pick their move? Yep.
They can use the positions of the array. So like because it's a three-dimensional array, like the 0, 1, 2 across and 0, 1, 3 down. So
Yep. So they can use indices of the array. All right. So let's do that. So if we're going to do that, then we want to open game again. We read two integers. And maybe we should tell them how they should do this. So by writing down the two integers with a space in between them, and once they tell us their move, we set position I, J equal to P. And that's what that was called, right? Set position I, J, and the value. board, it's B. Okay, player X, make your move. What should player X play? Yep.
Bottom left corner.
Bottom left corner. I don't know what that means. Tell me what player X should play.
0, 3, 2.
Close. Now what? Player 0. Player O. 3-0? 3-0. Ah, can't play at position 3. Its indexes are 0, 1, and 2. So, game-breaking bug. Can't continue now. The game is broken. So there we have some issues. A little playability issue. Might have been helpful if maybe the board showed us the indices. That could have helped. So maybe we can just improve playability right now just by printing those indices. So we do that. Oops. Not quite. We forgot. Still not quite. We forgot this. Okay, so at least now you have some guide to tell you what your move should be. Okay, now player X, pick your move. 0-2. Okay, player O, pick your move. 2-0. Player X. 1-1. Player O. 0-0. Player X. 1-2. You sure about that?
Oh, they win.
Well, player O is going to win. Are they? What do they play? 2-2. 2-2. And now? Player X? 0-1. Are you sure? 0-1? Nope. It goes row first, then column. 2-1. All right. O wins, but the game didn't notice that. So 2-2? Good job. So nothing prevents a play from happening where it's already happened. So there's still quite a few things here. We're recording things properly, but somehow the rules got lost in all of this. So, all right, so let's try let's do a few things here. So maybe we should enforce the rules a bit more strictly. So this set position value, set position thing, maybe it should only let you play in a square that is empty. So we only want to let you play there at position ij if there's nothing there. Then we do that, and we return true. Otherwise, we'll return false. Okay. So set position now will at least not let you set something that's already there. And so if I go to this game, I better be prepared to deal with the case that that the user gives me something bad. So Java has this nice thing called a do loop, which is handy when you want to do something at least once. And this is a perfect case of something I want to do at least once. I want to get the users play. If they mess it up, then I want to make them play again. Okay, so I'm going to play 0, 0 for x. That appears there, and now I'm going to try 0, 0 for O. And I get a... So what's happening now? It's waiting for me to try again. So it failed. It's executing this loop again, so I can do a 1, 0. And then it lets me play there. So should move this print statement inside that loop. So it's not a ton of feedback, but at least it shows me that something's wrong with what I just did. Okay, so good. So that prevents illegal moves, or at least overriding the other player's move. What else? What's going to be the hardest part of this whole game, actually? The winning condition. We have to decide when somebody wins. So natural place for that is in the board. So we can do something like asking for the winner of the game. So how do we determine a winner? So when do you win at Tic Tac Toe? Yeah. When you make a line. Okay, so what does that look like?
So you have the X or O as straight line going across, going down.
Okay. All right, so let's see. It can be a straight line going across, horizontally, vertically, or diagonally. So let's try and get the horizontal lines. So there's 3 possible horizontal lines. We can check each one. So is that a winning case? If position at 0 is equal to position at 1, and the position at 1 is equal to the position at 2, yeah?
No, because that empty spaces.
Yeah. So this will declare, if this is our rule, this will declare the 0 the winner, which is nobody. So that's not great. So let's add something to that. Board at I at 0 is not equal to the empty space. And I at 0 equals I0 equals I1, and I1 equals I2. So then we have a winner, right? That means that either all three of those are X's or all three of those are O's, and we don't care which. We can just tell the user that it's whoever played that position. Okay, so that'll test for all three rows if they're winners. We can do the same thing for all three columns. One, J. So this will detect if there's a winner on any of the three, the three verticals, right? So if you fix the column, that's the second coordinate, then you just check if 0, 1, and 2 all have the same value, and that value is not blank. Okay, and then finally, diagonals. There's a clever way maybe to do them both at the same time, but let's go with the not clever way, and that is if the board at 0, 0 is not equal to underscore. Okay, and what does the other diagonal look like? So we have diagonals at 0, 0, 1, 1, and 2, 2. What does the other diagonal look like? So 2, 2, 1, 1, 0, 0?
That's the same thing.
That's the same thing. Yep. 0, 2, 1, 1, and 2, 0. Yep. 0, 2, 0, 2, 1, 1, 1, 1, 2-0. Okay. And none of those things are true, then we return nobody. There's no winner yet. Okay, good. So now we have this thing called get winner, and that's good because we had this while loop here that was going forever. Well, we don't want to go forever. We'll go until there's a winner. Give it a whirl. It's not. Get winner is a method of the board class, so we need to tell it that. The winner is player. Player blank. Fishy, maybe better. Get winner function. No, that's correct. Get winner is returning 0, meaning that there is no winner. Oh, that's the mistake. So while there is no winner, we should continue. Okay, let's make a winner quickly so we can test this thing. X is going to play 0-0. And O is going to play 1-0, X is going to play 1-1, and O is going to play 2-0, and then X is going to play 2-2. And good. So that works. It says that the winner is player X. Didn't quite finish up by showing the final board. It just cuts you off at the end, but we can fix that up. Okay, so assuming that all works, I mean, we'd have to test the get winner code more carefully. There's a lot of cutting and pasting there. There could be a mistake. Anything else you want to see done?
Don't have a tie.
Aha, that's a good point. So if we play to a tie, what's going to happen? Yeah, we're stuck in the loop. And where exactly do we get stuck, or how do we get stuck? Yeah, so if you play 9 rounds and there's no winner, then the board is full. It'll be player, on the 10th round, it'll be player X's turn again, and no matter which move player X picks, it's not going to let him play. It's just going to keep asking him for a move because there's no valid moves left. So we need another termination condition, and that is while the round is less than 9. So while it's round less than 9 and there's no winner, then we continue. Okay, so that'll end the game after 9 rounds, and it'll show the board and it'll say the winner is player blank. So we can accept that, or say put an if statement here that says W is 0. The game was a tie. And otherwise, player W was the winner. Anything else missing?
Definitely white, the O is still before X.
Is that right?
I think so.
Who plays first in Tic Tac Toe? I always thought it was X. X goes first, I thought. Anyway. Okay, so if that's it, we'll leave it at there for today. And I don't know what we'll do next class. Something different than this.